Good morning if you're in Australia, good afternoon if you're in New Zealand or the Pacific. Welcome to our latest NAFES webinar. I'll just get rid of that recording that's on the screen, so you will have all probably got that. So just noting that this is being recorded today, and so if you're a bit shy, maybe you want to turn off the camera. And if most of you could, if you're not talking, put yourself on mute would be great as well. Our latest or first NAFES webinar for the year is brought to us thanks to our friends at AIRAH, Australian Institute of Refrigeration, Air Conditioning and Heating. They have recently put together a best practice guide on commercial kitchen exhaust management. So a special technical group that includes some NAFES members got together and came up with a guide to help us all interpret the standards around commercial kitchen exhausts, and anyone who's had anything to do with this area, I'm sure will be happy for further guidance. When we go out to ask people what they'd like for future webinars, we always get requests for more clarification around commercial kitchen exhaust. So this is your opportunity to hear what the esteemed team have put together, and hopefully it does give you a better understanding of the standards and how to interpret them. So what we're going to do today is, from a format perspective, it's about a 35-minute presentation. We're actually going to go through the entire presentation with the speakers first. If you do want to ask some questions during the presentations, what I'll ask you to do today is put them in the chat. We'll leave them till the end, or you can just save them up and ask them verbally at the end when we get to them. As I said, we've got a full hour, so there's that 35 minutes of the presentation. So what I'll do initially is pass over to Graham Williamson, who's the Managing Director of Lotus Commercial and Chairman of the committee that put together the guide, who will introduce the group and what they've done. And then there'll be Marcel from Stoddart's, Bill Sinclair from Dunbray, and Sven below me from AOM. They're all going to do a section on this. So I think you'll find it pretty informative and educational, and remember to ask questions as you need, and we'll get to those in time. So Graham, thank you for joining us. I really appreciate your engagement with NAFES on this subject. So yep, I'll hand over to you.
He says the motor's going round, but the blade isn't.
She probably stuffed it.
Okay, good morning, everyone. Thanks, Kerry, Jennifer, for providing the opportunity to present this morning on the best practice guide. The best practice guide has been developed under the banner of AIRAH, which Kerry referred to before. It's the Australian Institute of Refrigeration, Air Conditioning and Heating. Included in that is also ventilation. Within AIRAH, it's a not-for-profit technical organisation here in Australia. They have a number of special technical groups, and the kitchen exhaust one was formed around 2 to 3 years ago now, and is one of 9 technical groups. The initial focus on the kitchen exhaust technical group, it came together, I guess, because of a collective view of a number of stakeholders in the industry around some of the shortcomings in the standards, or a lack of awareness of some elements of the standards. And what that then manifests itself into is a higher level of risk. So what we've set out to try and do is to provide a source or a guide that helps a lot of stakeholders across the sector. So the platform, it promotes a whole of supply chain perspective on the commercial kitchen exhausts. The best practice guide itself, it's split into 4 sections, and it's essentially the 4 sections that the presenters will go through today, covering off design and installation, inspection, cleaning and training. The really important thing to note on this, the guide is free. So all you need to do is to go onto the AIRAH website, and it's freely available, and purposely so that it encourages people to actually download it and absorb what's in there and use it as they need to in their organisations. The development of the guide, not surprisingly, the starting point was certainly the Australian standards. And the main ones are AS 1668 from a design and installation, and 1851 from a cleaning perspective. But then the group certainly set about trying to understand what other standards were in existence around the world. And in the US, that includes NFPA 96, and it includes the various ANSI ICACA standards. And in the UK was probably the other major source that was drawn upon, TR19 Greece. So TR19 Greece, it's actually been extracted out of what was TR19 previously, and it's quite a good document if you're looking for some further background reading on the subject. And the guide itself is really put together to assist stakeholders right across the sector. So that's all the way from design and installation, manufacturers, engineers, contractors, owners and operators of commercial kitchens, landlords, insurers, regulatory bodies, emergency services. So it's there as a guide for a whole range of stakeholders that have some interest in the subject matter.
Okay, taking over from Graham, thank you, with regards to the regulations behind the best practice. I just want to give you the background, which a lot of you will already be aware of, but I think it's good to go to the 101 section of it. So firstly, the standards that Graham referred to are referenced by the codes. The National Construction Code is brought into legislation by the states and territories that make it a requirement for new buildings, and as well as new work on existing buildings. So generally, the time of application is when the DA is done, and when the DA is approved is normally the time that the revision of the NCC is referenced. So in recent times, the NCC 2019, which was brought out in May 2019, was amended. The amendment took effect from July 2020, and the NCC 2022 has been around, and most of you would have had access to look at it. It comes into effect on the 1st of May. So the states and territories have agreed to adopt it 1st of May, but each state and territory will adopt either all of it or part of it, and there'll be sections added to the back of the preview with reference to each state's adoption of it, which is not there at present but will come. The NCC, the National Construction Code, is a performance-based code. So it looks at best practices, or it opens it up to best practices and evolution of things over time, and it sets the minimum performance requirements to get safety, health, amenity, accessibility and sustainability in the buildings. And it really delivers two pathways to achieve the performance requirements, either through the deems to satisfy provisions in the standards that it refers to, or through a performance solution. It goes on to explain what a performance solution is, but I think it's important that because of the confusion around performance solutions, the Australian Building Codes Board has published a handbook for the performance solutions, which is very good in stepping out the process. But in a nutshell, it says that you have to meet all the performance requirements through the assessed methods, or be at least equal to the deemed to satisfy methods. And there are about 70 performance requirements across the 9 sections of the NCC, which are stepped out A through J. The one that's referenced quite a lot for kitchen ventilation is section F, which is health and amenity. And health and amenity moves from part 4 to part 6 in the changeover from NCC 2019 to 2022, but it's in essence, a lot of it's still the same. So it'll be part F6, light and ventilation. It has 5 performance requirements in that section. The first 2 are to do with light, natural and artificial light. The other 3 are really the crux of ventilation. And these are the performance requirements that we focus on a lot with anything we do with kitchen ventilation. In essence, it's maintaining adequate air quality inside the building, controlling the circulation of odours and harmful contaminants, and making sure that you don't unduly create a nuisance or hazard to people in the building or neighbouring buildings. And I think those three performance criteria sort of roll into everything that's in the standards that they refer to. There are other performance requirements that fall in line with that. The spread of fire and fire protection, they are obviously in the hazard part of the previous requirement. And then the sound transmission and condensation fall into the hazard and nuisance side of things. The NCC also refers or details 12 deemed to satisfy provisions, and you can see them. They have a D in front of them rather than a P, and again, those 12 have 3 that really reference the ventilation. 4 that reference ventilation, which is mechanical ventilation of rooms, natural ventilation of rooms, borrowing air from other adjoining rooms, so movement of air between rooms, and the local kitchen ventilation, which refers to the Australian standards. The important thing to remember is that those performance requirements are not a tick and flick. We often hear people saying we've got to tick the box to get through a requirement of the standards. They are ongoing requirements. The performance requirements are about maintaining and controlling. So it's important to have ongoing performance. So the risk of fire, it escalates as time goes on, and you have to maintain the systems. Likewise, you've got to have access to get to them, to maintain them and clean them, and give the procedures and training to people to be able to provide ongoing operation. So on that note, I'll pass on to Bill to give some more about the interaction between kitchen and exhaust system.
How do all? Can you just flick that next slide up, please, Marcel? Thank you. Here on where we're talking more about the integration of the cooking line and the hood, as whilst it's interlinked with the rest of the system, there is a very close relationship to that. I'll try and keep this section as short and sweet as I can, because the guide is really not targeted specifically at this, although it does touch it in sections, and really today is more about the guide. If we do have questions that are a bit off-piste with figurative description in regards to the guide, we'll try and answer them succinctly, but we may have to take them offline if you want a more detailed answer, or perhaps it can be subject to a later one. I've also got a cough, so that's another reason this is going to be short and sweet, which is probably beneficial to you all. There's also a number of bits that cross over between what Marcel said, what I'll say, what Sven says, and that's because this thing is quite interlinked. Okay, so if we look at the integration in the slide we've got there, there are 2 methods which Sven will detail in his presentation more, that you can use to work out airflows, hood sizes, whatever, prescribed and performance. Both of those have an intrinsic link into what is under the hood. And that affects the amount of airflow required, i.e. a wok requires a lot more airflow than an induction hob. It affects overhangs because of things like combis, which blow steam out when you open the door and you get breach. It affects the filter type. So what we have there is a statement in AS 1668 with reference to using UL 1046 fire rated filters. In the Act, it says both 10 metres and open flame source. We tend to look at it as either or, but that means you can't use a honeycomb filter over something like a char grill, as an example. And then clearance. And what we're talking there about is that's that section in the Act which always causes confusion about the height from the cooking surface to the throat of the filters, okay? And all of that is affected by what you stick under the hood. Next one, please, Marcel. So you get into a situation of compliance. Now, if you don't take into account what's under the cooking line, you can become non-compliant. And the potential risks of that is you can negate the customer's insurance, you can open up potential legal action against the customer, and you can open up potential legal actions yourself, because many of you are CSFPs and you're viewed as an expert. So if you've said to the customer, you can put this under there and it's all good, there's going to be some ramifications if something goes wrong. And a big point to understand is you just can't change the equipment under an existing hood or under a new hood and assume that it'll be remain safe and compliant. Now that's both, as I said, in an existing hood where you're swapping kit around, or it could be a situation through the design process where the requirements of what are under the hood change. Then you almost certainly need to revisit what the hood needs to be with reference to the size. It's important to build flexibility into the system, okay? What happens today, I could assure you, and I'm sure you would all agree, is not going to be how things are in 10 years' time. So if it is possible on a new build or a refurb that you can get some extra flexibility into the system, that's a great benefit. Additional airflow, a slightly larger footprint, a setup with the 1046 fire rated filters, etc. All of those things are helpful in moving down the track, because this is not something that's there for a day. You know, this is years of capital investment. Next one, please, Marcel. Okay. The importance of integrated kitchen design: safety. A non-compliant design can render the kitchen safety. So the potential issues are things like fire risk, incorrect design or filters, or mixing fuel types in a standard system. Number of times we've seen portable hibashis plonked on top of benches under a standard hood system next to a fryer. Very bad potential for fire risk. Carbon monoxide build-up. So if the ventilation, as per Marcel's section, isn't adequate, or the drawer isn't adequate, we can have a CO2 build-up if we're using fuel-based equipment, and that's dangerous. Food safety, things like grease dripping down on the food because of the hood design being incorrect, etc. Then we have the kitchen environment, and that's sort of interlinked with the safety, but it also has an impact mainly on your staff. So excess heat reduces staff efficiency significantly. There was an FCSI webinar, I think November and December, that spoke quite a bit about this and this issue. So go have a look at that if you want. Thermal radiation, that's the distance from the front of the cooking surface backwards to where you might place a bench or a pass to allow the staff member to move away from the cooking surface, okay? Fumes and smoke. If there's ineffective capture, you can have fumes and smoke in the kitchen, which are detrimental to your staff. Noise, if you've got too much airflow or the insufficient acoustic attenuation, you can get the dBs up too high, and that's bad for your staff as well. Poor visibility. If the lighting is insufficient, you know, people are working with hot, dangerous things under a hood. Lighting is really important. And cleaning. You've got to be able to clean the hood. So you have to be able to get all those nooks and crannies and get the grease and the muck and be able to get at the wall at the back, okay? So that's a very important thing, and that's touched on again later on by Graham in detail, because cleaning is pivotal. Next, I think that's it. Is there one more, Marcel, please? Oh, and just a quick touch to say we are seeing a greater proliferation of self-capture equipment. And that's due to a lot of stuff where they're plonking a food service operation into, say, a ground floor of a multi-level building where you've got residences or retail or whatever above. Just be aware that stuff that is certified, like the self-cleaning stuff, does have some caveats around it. You know, you often see certified self-reticulating stuff on combis. You see catalytic converters and speed ovens. We see equipment below 8 kilowatts, the countertop stuff. We see self-condensing dishwashers. All of that, you just got to know that that stuff that's not under the hood has to be taken into account, that you're not allowed to exceed 0.5 of a kilowatt per square metre of the kitchen space of that type of equipment, and that it has a similar effect, not exactly the same, but a similar effect on your environment and your air conditioning. You know, if you add a 17 kilowatt self-ventilated combi in the kitchen, you don't necessarily do the full amount, but you do put a load onto your kitchen air conditioning. And not all certifications from all manufacturers include all cooking processes. So just be aware of that when you have a look in the spec sheets. That's it.
Yeah, thanks, Bill. Good morning, everyone. So this section of the presentation refers specifically to the third section of the design and installation, or the best practice guide, and it talks about knowing everything that Marcel and Bill have now said. It tries to condense everything into a section where we look at the design and installation of the kitchen exhaust system, and how already at that stage we can significantly reduce the overall fire hazards and the health and safety risks on the building or premises. And that's done by two main elements. The first is that complying to all the relevant codes, NCC performance requirements, standards, regulations, and best practice guides will significantly minimize the risk of a fire ignition, will reduce the fire spread, and will also help in suppressing any type of fire event as quickly and safely as possible. And the second key element is that already at the design and installation phase, we can plan for optimal maintenance of a kitchen exhaust system. And as I think it was Bill has said previously, maintenance is key as well to ensuring that over time, a kitchen exhaust system doesn't increase in risk. The challenge, of course, is a kitchen exhaust system is composed of a whole bunch of different elements, often that are supplied from different sources, that have to come together to form this one perfectly working ensemble, almost poetry in motion, one could say. The additional challenge there as well is that we're talking about two main trades within a project. Under the ceiling, we have all kitchen designers and contractors. Above the ceiling, it's all the mechanical trades. So those two trades also have to coordinate together to form this one functioning system. So here you've seen this little schematic in Bill's side of the presentation. It's also in the best practice guide, and it really tries to detail all the elements of the kitchen exhaust system. And what the guide does with all these different elements is provide guidance, and which is linked to the standards requirements as to how each of these different elements should be designed and or installed. So if we look just briefly at some of the different components of the kitchen exhaust system and what influence it can have on the fire hazard of the overall system, Bill already detailed the importance of the cooking equipment that goes under kitchen exhaust hood, and that's where everything starts, is really to look at what the different components of the cooking line are. Of course, a solid fuel exhaust is going to be a lot higher fire risk than an induction cooker. In 1668.2, there's a breakdown of 7 different cooking types, and that influences the overall design of the kitchen exhaust system. So typically, the hood will be strongly influenced by those different cooking processes, be it in terms of airflows, overhangs, and those are the two main, and size of the overall hood. And as Bill has underlined, any changes in a cooking line will significantly, or has the potential to significantly influence the overall performance of the system. And then you have your grease filters, which are under the hood, which are also the types of the grease filters are tied to the fuel source, as well as that distance between the fuel source to the grease filter. Now, if we go in a way above the ceiling, there are different elements here that the design guide looks at as well. Of course, the makeup air coming back into the room. Makeup air will or the right design of makeup air has the capacity to significantly influence how an exhaust system performs. So there's an importance to that element there. The overall design of the ductwork needs to meet 1668.1 requirements in terms of the manufacturing. And there are elements there in the standards that underline how to design and install ductwork to ensure that fire or the risk of hazards is minimized. And the main element to that is the access. So access panels into the ductwork, but also the requirements for safe access to the different elements of the kitchen exhaust system. So that can be access panels and doors, work platforms, stairways, ladders. How do you first get to these different components to then be able to service them? And the trick there is, notably, it demands a coordination between trades. Then when we go higher up, the design guide looks at the different means of additional treatment of kitchen exhaust that can be put into a system. One, mainly to minimize the potential risk of nuisances of a discharge, but also they can have an influence on a potential fire risk downstream of a filtration plant. Then there's the role of exhaust fans and their role that they play in managing a potential commercial kitchen exhaust fire, notably to evacuate or to get rid of the smoke out of a kitchen. And then there's the guide touches upon, though it's not the main role of this guide, to look at the discharge points and either vertically or horizontally, and how to minimize the risk of nuisance, which is one of the performance requirements that Marcel had touched upon. That's a topic that could form a whole new guide. So having a look in just very briefly, because this is a question that often comes up, is the role of solid fuel cooking. And here we've just got a slide of special consideration. So 1668.2, as the NCC demand to satisfy pathway, does not allow for mixing of a solid fuel cooking appliance with a non-solid fuel cooking appliance. Bill said, stick a hibachi grill in the middle of a cooking line. So that's all of a sudden you're non-compliant. The reason there, of course, is that solid fuel has the potential to bring sparks and embers into a kitchen exhaust system, as well as often with pizza ovens, extremely high amounts of heat, whereas non-solid fuel equipment leads to the buildup of grease within those systems. So you effectively, when you look at that fire triangle, you effectively have the ignition and the fuel elements, and with the overall exhaust system, there's a whole load of oxygen in there. So you're really building up that risk of the fire triangle. So in theory, you should have two separate systems, but of course, that's not always the potential. There's not always the potential to do that. And in certain cases, buildings don't allow for it, and you have to then move to combining both systems together. So there you enter the performance design pathway, as Marcel underlined, and there you have more work to do to ensure that you meet the compliance, the performance requirements of NCC.
Okay, thanks, Stan. Just before I get into the next slide, I just wanted to make mention, Kerry indicated earlier on, we've got some people from far and wide that have joined the call. I just wanted to acknowledge quickly Grant Mogford, who's joined all the way from California. Grant's on the committee of ICECA in the US, which is the International Kitchen Exhaust Cleaning Association. And the guys over there have been very supportive and interested in what we've been doing. And it's a relationship that moving forward, we want to continue to nurture and learn from some of their experiences in the US. So thanks, Grant, for joining us. I just saw your note on the meeting chat. The next slide. So we're getting into the standards, and this is sort of coming back a little bit to why did we see the need to develop a guide? When you're talking about the cleaning that insurers, landlords and others always refer to is AS 1851. And there are two tables in there that are specific to the kitchen exhaust and the frequency of inspection and cleaning. The first table at the top refers to a monthly inspection of the filters and the hood. And the one down the bottom talks about doing the same, the monthly service, but also then checking the duct and the fan as well. Now, the whole industry refers to this standard. But the quickest, easiest way for me to describe what the shortcomings of that are, if you compare and contrast an open flame grill hamburger restaurant to an aged care facility, they're at polar opposite ends of what the inspection and cleaning regime really needs to look like in terms of managing risk. So one of the key things is obviously to understand what's the style and type of cooking, hours of operation, that then should really be influencing the frequency of inspection and cleaning. In terms of inspection, what's encaptured in the guide, based on the style and hours of cooking, there's a recommendation there on how frequently the system should be inspected. And then down the bottom, there is also a table in there with I guess an objective way of trying to measure the grease buildup. And there's a reference there on the bottom right to a very simple tool, but it's one that's been put out by IKECA. We utilise them ourselves, but it's basically a depth gauge comb that measures the buildup of grease and oil in the system. The cleaning intervals on the exhaust, what we have here is just a recommendation on what the frequency perhaps should look like. But then over time, a combination of either inspections by the operators of the premises and the system, or a combination of that with whoever's coming along to clean the facility, you should then adjust up or down the frequency based on the evidence that you're finding in the system with the buildup of the fuel. Importantly, there is obviously a difference there on the solid fuel and a requirement for it to be cleaned a little more frequently for obvious reasons. The guide also has a very simple template, I guess, that provides a guide for service providers, but also for clients as to what you should be looking for from your service provider, whether that's the inspection report, which should include or outline the scope of work, the areas of work that's been undertaken, any areas that are not accessible, which unfortunately is more common than everyone would like, and any recommendations you might have to be able to improve the access into the system to achieve 100% clean, and then a recommendation on when it should be next cleaned. And then on the right, the certificate, which is always what the insurers and the landlords are looking for. So an outline there of the sorts of things that you might expect to see on the certificate. I think this is the last slide on the training. There are certain areas that are highlighted as being key for people involved in the space. So risk management, being able to undertake the inspection of the exhaust system, understanding the different components of the kitchen exhaust system. I think it's probably fair to say, and the closing comment that I would make is that the guide has been published, but the the technical group has a life beyond the production of the guide, and fully expect that there'll need to be future iterations or updates produced in the years ahead. So there is already a work plan for the year ahead. Some of the areas that are on there or may be on there in the near future, solid fuel, Sven has touched on, is a topic that is of particular interest because of the risks associated with it. And I think the training area is one that will likely get some further attention in the years ahead. And that would be one area where we would look to try and liaise with the likes of ICECA to see what might be possible in that space. The technical group, the last comment on it, I would say before we hand over for Q&A, membership of it is open to anyone. The only prerequisite is to be a member of AIRAH. So if anyone has a particular interest in the space and want to get involved, all you need to be is a member of AIRAH, reach out to myself or one of the other guys that are on the technical group, and you would be more than welcome to join us. So thanks, Kerry, and thanks, Jennifer, again for setting up the opportunity.
Thanks, Graham. Don't go anywhere because there's a few questions already coming through. First one's a basic one, which I probably should have touched on at the beginning. We will share this this presentation with everybody who's joined us today, so we'll send that out to you. First, probably question for the panel from Mark Minnis. Welcome, Mark. UK standard allows for some mixing with solid fuel. Will Australia look at modifying the standard to allow for modern solid fueled ovens? Not sure if anyone's got that visibility on what the standard might include or might not, but maybe the panel can confirm that or otherwise.
From an Australian standard point of view, there has been discussion by the committee about taking that clause out of AS 1668.2 on the basis that that was put in there in 2012. Since then, AS 1661 added its clause 6.2.9 about the UL classified filters for spark arrestants. So they said they don't want to duplicate, so they've possibly taken it out of 1668.2, but that would be, of course, subject to the committee deciding that and putting it into the next evolution of or next release of 1668.2. Until then, it sits as a performance solution, and in my opinion, probably should, because a performance solution always looks at the specific project rather than a general rule. And it really is such a critical aspect that it should be probably treated on a case-by-case basis.
Just on that, Marcel, you covered the performance solution in your part of the presentation. What's the recommended route to go down if you're in that sort of design process to look at performance solutions? What's the typical process you'd go down?
That guide printed by the Australian Board Building Code Board. Just flick back to it quickly. That code is, I think, an excellent document for anybody who wants to go that path. And it's critical, that first step of preparing a performance-based design brief in consultation with the relevant stakeholders. So it's an important thing to identify all the relevant stakeholders. So the fire engineers, the environmental engineers, the architect, the builders, the customer, the tenant are all stakeholders, as well as the suppliers and the kitchen designers. So all stakeholders have to be involved in the development of a performance solution and go through the process of determining what are the key criteria, what is the process of analysing whether the criteria is being addressed, and then prepare a final report that is endorsed by all the stakeholders.
Thanks for reinforcing that. Just on that solid fuel question, there was a comment from Grant in California, and it's great to have someone from California on the webinar. I think it's late afternoon there, so welcome, Grant. You've mentioned just in passing to the comment around solid fuel that the US prohibits the mixing of solid fuel exhaust with conventional system exhaust. So interesting that it's effectively outlawed in that market at the moment. Thank you for the comment. Wes, welcome. Always good to see you. Your question: ventless appliances and appliances with ventless hoods fitted, acceptability or compliance verification of the EPA 202 and or UL certification for them. What is the compliance mechanism or best practice to process that?
I can chip a bit there, and Marcel probably can too, but the normal path for a ventless certification that we would go through is that would be tested for compliance by a suitably qualified mechanical engineer, who would then certify the product as being compliant. And as part of that process, he would be the one who would request any changes to what you were doing with the appliance, because he's the one that's putting his public liability insurance on the line with the certification.
Thank you for that. I understand that, Bill, but if the appliance is already certified in US by UL, recognized certification body, and the application is all identical, so is there any mechanism to acceptance that?
I'm not aware. Are you, Marcel?
I think again it comes down to if it's not prescribed in a standard that's brought into legislation by the code, then it would have to be a performance solution, and it would either have to have a performance process or be demonstrated to be at least equal to the prescribed.
Yes, that's demonstrated by the EPA 202 testing. That's done in testing ventilation conditions and all to the limits, 5 particles per million, those kind of requirements, very much equal to Australian requirements. It's just there is no mechanism to acceptance that.
Well, the performance, you need to have a look at the performance solution publication and step through how you would get the certification for a product under that pathway.
I've been trying, and it's just getting nowhere. There is no clear way to clarify that. That's the problem. There is an option to go through certification, but that's basically just repeating the process what's already done in US or in UL lab and EPA 202 testing and all this. Just repeating all this, verifying this again for Australia.
My understanding that is the case, Wes, at the moment. It's not too different in my understanding to lots of other qualifications that are held overseas, doctors, etc., lawyers, where some do and some don't, are not accepted in Australia and require further clarification, qualification, whatever. So that's my understanding at the minute.
I understand if there are other aspects which are making Australian conditions different, but in this case, we are talking about the same application for application compliance. Nothing, no additional difference when that I can see, sort of, those kind of very basic, straightforward apple for apple comparisons.
Okay, it doesn't look like there's any further comment on that, Wes, but thanks for raising it. I'm not sure if anyone has any further information after the seminar or webinar, they can share that with Wes. I'll move on to the next question, okay. Thanks, Wes, which is from Kathy. Goodwin. Would not be a webinar from NAFES if Kathy didn't ask a question, so good to keep that record up. Small business are always cutting costs. Cleaning and maintenance was usually the first cost to cut. It's a worrying statement, but probably true. Is there a policing mechanism for non-compliance on the cleaning side? Graham, I think that's a question for you.
Yeah, no, I'm happy to answer that one. And thank you, Kathy. We'll have to put you on a commission for selling the guide, but unfortunately it's free. But look, this is very much what the guide is all about, is trying to raise awareness of what the risks are associated with these systems and provide some guidance on what should be getting done. The simple answer is no, there is not a policing mechanism. For a lot of small customers in particular, it's often a grudge spend to satisfy an insurer or landlord. So one of the challenges now with the guide is around raising stakeholder awareness of it, and we would hope over time getting insurers to refer to the best practice guide when they're having conversations with their clients around what they're doing. And ultimately the risk here is not just having a fire, the risk is around having an uninsured loss. So if the customer can't demonstrate to their insurer that they've been doing the right thing in the required time frame, that the real risk for them is not just having a fire, it's around having an uninsured loss. And in some cases, as we all know, in some premises, the collateral damage and the magnitude of that risk is certainly amplified in certain settings. So simple answer is there is not a policing mechanism. There are gaps there, which is why we've developed a guide. We're hoping that stakeholders far and wide will start to embrace it, understand it, and use it. And then in time, start to better understand and manage the risks.
Can I add something there, Graham, which is Marcel touched on it and we've discussed it many times in our meetings, is ongoing responsibility. The guide is about ongoing responsibility and continuance of best practice. And Marcel made it very clear in his presentation, it's just not a tick and flick. You just don't deliver the thing, turn it on and ride off into the sunset.
Thanks, Bill and Graham. There's a comment here from Jacques Moran, just in relation to the guide. There's only mention of hoods in the guide and in the presentation. A suggestion to add ventilated ceilings. It is part of the Australian standard since 2012. Assuming that's probably not part of the brief that you worked on, but is there any intent to do something similar around ventilated ceilings? Anyone?
I can answer that. Specifically, no. I guess ventilated ceilings are a variation of hoods, of exhaust hoods. They're still connected to an exhaust system, and I think the guide is very much directed as the whole of system and looking at the entire kitchen exhaust system from the kitchen through to the air outside, including the replacement air that you're bringing into the kitchen to replace what's exhausted. So a ventilated ceiling falls very much within that same scope. It's just a variation on it.
Cool. Let's see if there's any more questions coming through. Another one from Enzo. Is AIRAH aware of any new requirements for mechanical ventilation where gas appliances using hydrogen or hydrogen blended material gas may be used?
That's actually hydrogen blended natural gas, Gary.
Sorry, my fault.
I don't believe so yet. I seem to remember this from that one of the previous NAFES discussions we had.
Yeah, I think it's something that needs to be looked at both from the gas technical regulators and AIRAH because of the characteristics of hydrogen, and we do have some trial projects that are forthcoming, such as the Hype Murray Valley project in Albury Wodonga, where they're looking at blending up to 10% hydrogen into the natural gas network. So yeah,
What was the time frame on that, Enzo? I do remember you mentioned it last time, but I can't remember.
I believe they were talking about becoming operational at the end of next year, but I dare say that's probably not going to happen. It'll probably be 2025. So you're looking at about, you know, probably a year and a half to 2 years from now.
Thanks, Enzo. Grant's got a question, which is an interesting one, considering obviously this is a growing market. Does Australia have any standards for the inspection, testing and maintenance of food trucks? And I'm assuming that's any sort of temporary type kitchen setup, container kitchens, etc. Marcel, any thoughts there?
Not to my knowledge. I'm not aware of any standard.
So you'd effectively be using the Australian standards as per a normal fixed building. Is that what your interpretation would be?
Not necessarily, but I think the performance requirements would still apply, that you're not allowed to cause harm or nuisance to people within the room or truck or neighbours from a noise, pollution, contaminants and fire risk point of view. There are codes around obviously the safety of kitchens in trucks and containers, in the gas code and bottled gas on trucks and that sort of stuff, but outside the scope of what we're sort of doing here.
Grant's mentioning that the NFPA now has a chapter devoted to food trucks, which is interesting.
Yeah, thanks for that one, and that'll be something we can follow up. The other comment Brad had put in there earlier, Kerry, related to the role of the fire authorities in the US, and certainly they've got my perception is from afar, they have a real seat at the table around trying to enforce compliance. And when I was talking about the various stakeholders, or one of the challenges I think in Australia is trying to increase the understanding and awareness of a number of groups, but fire authorities, and see what role they can play in assisting with compliance.
It just sort of raises an interesting point as well in relation to your process that you've gone through and your comparison with between Australia and the US and the UK you mentioned. Where does Australia sit in terms of the standards, in terms of safety and progressiveness on a global level now?
Myself personally, and the others can chip in, but behind. Yep. And the easiest way perhaps to explain that was the slide that I went through on 1851. 1668, I think there's some areas that can be enhanced or improved, but I think in that case it's a lot more about awareness and understanding and compliance to what's actually in there. Plus I'm sure there's some further improvements that can be made. Both those standards, obviously there is a review time frame with standards. I think both of them are coming up, and we've got an opportunity, I think, in the year ahead to provide an input or a paper into the review of 1668. So my personal view would be behind, which is why the guide is being developed. In time, we would hope that some elements of what we've got in the guide can be backed into the standards, but I'd be interested in what the others think as well.
Any further comments, Marcel, Bill, Sven, on that particular question?
Well, looking at it from the design side of things as opposed to the maintenance, I think Australia, with the standards that we have and the NCC pathways deemed to satisfy performance, I think we fare quite well. I would say we're top of the class by far, but we fare quite well in being able to have that method of design that one is stringent with 1668, but then flexible enough with the performance solution to be able to be adjusted to different projects when that's done in full compliance. So from the design perspective, I think we're doing well. Always, as Graham has said, there's 1668 is about to be reviewed. So there's definitely potential for us and anyone to have an input in that and move it towards new directions.
Cool. I'll just ask the floor if there's any further questions. There's nothing come through on the chat. I'm not sure if anyone wants to open their microphone and ask any further questions. I'll pause for a second and see, but clearly not. So
Yeah, sorry, could I ask a question, please?
yeah, absolutely. Yep.
I don't know if you can provide the answer, but there's always an ambiguous situation with what happens as far as existing premises when they want to get a new appliance and the hood is either not up to current code, maybe it was previously, or maybe they put a non-compliant hood in the first place, and we're now changing an appliance to a new one. What's our obligation as far as, you know, do we need to tell the customer, well, until the hood's upgraded, we can't connect gas and electricity to something because it can't be operational? Or we're always a bit in the dark about where we actually sit legally or our obligation with that.
Clearly, you have to advise the client that the thing is non-compliant and that will probably negate their insurance, etc., etc. Whether you can legally connect it or not, you know, there's an old adage, and I have unfortunately a pile of legals in our family, and that is that everybody gets sued if something goes wrong. So from my point of view, I would be very careful about doing something like that when you openly know that you've pushed the environment into non-compliance. That would be my personal opinion.
And of course, the problem we always have is not everybody cares about doing the right thing. So we'll have competitors telling customers it's not a problem. And when we bring this up, of course, then they just shy away from us and go elsewhere.
But if the building burns down, that's probably a good thing.
Exactly. Yeah. Well, I agree with what you're saying is that, you know, if there's a legal responsibility and issues with insurance and stuff, then we can't make that our problem.
Just one final comment's come through from Michael Jones. On food trucks, I've designed and built dozens if you'd like to know more. And with relation to old existing canopies, he's saying always pull down and replace. So there you go. It's the easy solution. Not always the cheap one, though. Well, thank you, everyone. We've come to an end of the presentation. I'd really like to thank Graham, Marcel, Bill and Sven for giving up their time, not only today, but in preparation for this, and also obviously in preparing the guide. I would encourage you all to download a copy of that guide. As we said, it was free. So there is a link in this document, but otherwise go to the AIRAH website and hopefully you'll be able to find it relatively quickly. If you've enjoyed the presentation, found it informative, I'm sure reading the guide will give you even more information and will be a useful source of reference. Just from a NAFES perspective, we've got our online CFSP course. We had it actually this week, great participation as per normal, and it was sold out, as they always are. So if you want to get into the June course, 19th to the 21st of June, suggest you get in quick. There'll be limited places available. Otherwise, if you can't make it to that one, there's one in October, the 23rd to the 25th. Just a few events we've got coming up as NAFES. Our industry dinner, as per normal, is combined to coincide with the Fine Foods show in Sydney this year. So that's on the 11th to 14th September. Tables are selling out quickly. So if you want to get a seat or a table, contact NAFES. Finally, not on this slide, but we will be having another webinar in the next couple of months. At this stage, we've got penciled in the 15th of June, and quite an important topic for those in the industry, which is around electrification. What's the future of gas in the commercial catering field, which will also apply obviously domestically as well, as we push towards a more electrified power system. So there'll be some very interesting speakers in that one, as we have had today. Who'll give you the latest on what the developments are in that particular field. So that's likely to be, as I said, 15th of June at 2 p.m. Australian Eastern Daylight Time. It'll be then, no summer times. So once again, thank you for coming. Thank you especially to our presenters. Really appreciate your attendance and support. And thank you for all those that have come along to listen here. And we'll send notes out. But thank you again. Take care.
Thanks, guys.